Hi, we can solve this problem together, but as we do, keep in mind that it's going to be better for you if you try to work ahead of me, think about the problem for yourself, and not just follow what I say and do. So the first thing that you should do is go ahead and read the problem, underline the things that you think are important, and think about what kind of problem this is. So go ahead and take a minute to do that. So you should have realized that it asked you to solve for total potential energy. This means that we have to find potential energy elastic and potential energy gravity. Look at what I underlined. See if it matches what you underline. I underlined 51 kilograms and said that that was a mass. I underlined all of these measurements in meters, the 321, the 104, the 179. None of these is necessarily X or H, but we'll use them to figure those out. And I also underlined the spring constant, which is K, the 32 newtons per meter. Okay, so where are we going to go with this problem? We can't really go too far until we figure out what the X and the H are. So let's consider this. We've got this bridge, and it's over a river. Well, how much distance is there between the bridge and the river? So that's the 321 meters. The 104 meters is how far I could extend that bungee cord and it would be completely relaxed. So if there was no weight on it, the bungee cord would go to 104 meters and it wouldn't have any kind of elastic potential energy. However, when this jumper drops off, he's going to create some potential energy elastic. So how much will that be? Well, you have to consider how far he goes down. So we should label a third length, and it's 179. This is how far the bungee cord jumper has actually gone down. Okay. So what do I need to find with this information? I need H, the jumper's new height from the river, and X, how far the bungee cord stretched out. How am I going to find these? Well, let's think about the bridge. Okay, it's 321 meters above the river. It says that when he jumps, he's left at 179. I'm sorry, he's not left at 179. He goes 179 further down. So what he's left with over the river, that's his height that I've got represented here in yellow. So if I say, okay, he started 321 above the bridge, he went down the distance of 179, he's currently at 142 meters. That's my height. So what do we need to consider now to find X, or basically how far the bungee cord has been stretched? What's not relevant here? So I don't necessarily need to know as much about the 321 meters as I do about the fact that this bungee cord has stretched. So the 179 meters can be further broken down. Think about how much of that 179 meters was actually stretched. Well, if I think about it, here's my 104 meters that was already able to be just relaxed, and then the other part of it is the part that's stretched. So if the whole thing is now at 179 meters, 104 of that would already have gone down just because that's how long it was, but it's stretched out to go additional to make 179. So 179 minus 104 is 75 meters. That's the amount that it's stretched, so that's also known as X. So now we not only have the M and the K that were originally given to us, but now we have X and H, and that's enough information to solve for total potential energy. Okay, so what's the equation for total potential energy? we're going to add elastic plus gravitational energy, where elastic energy is 1/2 kx squared and gravitational energy is mgh. Now I can take everything from up here and just plug in. So 1/2 times k, we noticed k up here was 32, times x, which we figured out to be 75 squared, plus m is 51, g is always 9.81, and h is 142, which we calculated a little earlier. So now let's go ahead and multiply this part first to find the elastic potential energy. So you should have gotten 90,000. Now what about on the other side when you do the gravitational potential energy? 71,044.02. And now you want to add them together for total energy, which is 161,044 if I just round to the nearest whole number. So what do I still need to do here? That's right, I always want to have a unit. In this case, it's going to be joules. So we've worked through this problem together. Make sure that you understand it well, and if you don't, go back through this again, because next time you're on your own. All right, good luck.